As you said, my name is Quinten McNamara, and I work in the psychoinformatics lab at the University of Texas. So if you put off lunch long enough, you'll see some cool brain images at the end of this presentation. And today I'm going to talk about our work developing a package called Pliers, which is our comprehensive framework for multimodal feature extraction. So just to quickly orient you guys on what we're talking about here, this is just a simple overview of a typical data science pipeline. And for this talk, we're really focusing on feature extraction. So the process of taking your raw data, be it images or audio or whatever, extracting meaningful features from that and inputting these into a model. And so in particular, we are motivated by the challenging use case of having a very complex data input, so something like a video. And since this has visual and audio components, there are many, many different things that you can extract from this that could potentially provide value to your model. So let's just say, for example, you're interested in just extracting some high-level feature object recognition tags. So you look up the Google Vision API, code up this very quick interface with it, and get some cool object recognition tags. But then you say that, my buddy said that Clarify API is also pretty good at doing this, so you code that up as well. And in addition to all of this, you also want to control for some low-level features. So you look up on Stack Overflow how to extract edges or color histograms and things like that. But then you also notice that on your video, there's a lot of text appearing on the screen. So now you look up the Google Vision API to run OCR. And now that you have text, you want to do some text feature extraction to help inform your model. So you do sentiment analysis or pause tagging or stemming and a bunch of other different potential natural language features. And so what you get with all of this is a big mess of code. And in particular, it becomes very difficult to maintain and manage as you're writing domain-specific code to interact with each of these feature extraction interfaces. And furthermore, you have to consolidate all the output in a format that you can use for your data science pipeline. And so that's where Pliers comes in. So Pliers is an open source Python package where we wrap a bunch of existing feature extraction methods into a single interface that is standardized, easy to use, extensible, and multimodal. And there's our GitHub link too. And so now I'll just unpack each of those concepts. So first of all, we wanted to build Pliers to be very standardized and easy to use. And to do this, we incorporate a very high level of abstraction. So allowing users to perform more complicated feature extraction methods using a few lines of code and not having to deal with the nitty-gritty of feature extraction. And another part of making it easy to use was establishing a uniform Python API. So each feature extraction method is interfaced just by a simple transform method. And we took this inspiration from scikit-learn. And then secondly, we wanted Pliers to be very extensible. So this is important since there are so many feature extraction methods out there. We want new users to be able to add their own custom feature extractors and as well as contribute and add new feature extractors or even input types to our framework. And so kind of building on that concept of different input types, Pliers is inherently multimodal. So a lot of other packages that currently exist for feature extraction focus on one particular modality, like NLTK and scikit-learn for text, or OpenCV and scikit-image for images. But with Pliers, we really want to be able to interface with a bunch of different feature extraction methods for many different input types and consolidate this into one framework. So currently we have support for text, video, audio, and image feature extraction. And so now I'll just kind of walk through a simplified version of the architecture for Pliers. So there are two central concepts. The first of which is stimuli. So that's just any type of data input from which you want to extract features. And then secondly, we just have transformers, which is anything that performs an operation on some type of stimulus. And so this is just a quick view of the hierarchy for a stimulus. So as I said, we have support for image, audio, text. Now recently we support extracting from Twitter stimulus. And then this is also a quick overview of a hierarchy for transformers. So there are three essential types for transformers. The first one being extractor, which is the core of Pliers, is anything that takes in a data input and outputs some type of extracted feature or real value. But then we also have converters, which will perform some type of type conversion from one stimulus type to another. So a classic example of this is OCR, which is just transforming an image into text. And then lastly, we have the concept of filters, which just applies some type of transformation to a stimulus and outputs the same type. So some examples of this would be stemming for text or image cropping for images. And this now I'll just give a quick overview of some currently supported transformers we have in Pliers. So firstly, we have, as I mentioned earlier, some wrapping for object recognition services. So we have the Google Vision API and the Clarify API. And then we also wrap some methods from the OpenCV libraries to perform some low-level feature extraction. And for text, kind of the same thing. We have wrapping for the Indico API to do sentiment analysis and other high-level text analysis. But then we also have some methods from NLTK feature extraction in Pliers. And then lastly, for audio, we mostly just have converters that take audio and will extract the text. So two API services that provide that for us are the Wait AI API and the IBM Bluemix API. So kind of going back to the concept of converters and filters, it kind of naturally forms that you can start chaining up these transformers. So you could have several converters and filters linked together that do some type transformation, and then follow that up with a final feature extractor. And a particularly easy way to do this in Pliers is through the Graph API, which allows you to specify more complicated workflows for feature extraction that includes some branching of type transformations and things like that. And so all of this can be easily specified and run, and then the output is all consolidated. I'll show a quick example. So that is just some code that generates a Pliers graph. And so something with that few lines can generate something that looks as complex as this. And so now I'll kind of just walk through each part. So the user firstly specified a frame sampling converter, which just takes in their input video and downsamples to a smaller set of frames. And then the user also asks for a bunch of different extractors that take in image, audio, and text alike. And so you may notice that the user did not explicitly specify any conversions, but they did request sentiment analysis, for example, using the Indico API. So Pliers is smart enough to implicitly insert some conversions in there when feature extraction of a different type is expected or is requested. So the input is video, but Pliers implicitly converts it to audio and then uses the IBM speech-to-text transcription service to convert it to text before running sentiment analysis. And the last thing to note here really quick is that the user doesn't explicitly specify their input types. They just give a list of files. So just that's one neat thing we do. We just use the file metadata to implicitly load it into the correct Pliers stimulus type. And so going back to what I said earlier, we really wanted Pliers to be extensible to allow users to customize and expand the library. And so, for example, it's really, really simple to implement a new extractor. All you have to do is firstly implement or define an input type, and then implement a simple feature extraction method. So, for example, if you want to do a simple extractor that takes the length of a text document, it could look as simple as this. So you just specify the input type as text, run your feature extraction, and wrap the extracted feature into this extractor result object. So kind of building off of that, all of our feature extractors produce this same extractor result object as a standardized output. And this class contains a lot of different methods to manage and merge results across different feature types and stimulus types. And it can be conveniently converted into a pandas data frame, if you're familiar with the Python data science stack, for ease of use in a pipeline. And so another feature of Pliers is that we have scikit-learn integration, so you can take any Pliers graph or extractor and wrap it into a scikit-learn pipeline pretty conveniently. And then finally, we have basic support for caching of repeated transformations and parallelization across iterable inputs. All right, so what can we do with this? We believe that Pliers is a general package that can be used in a lot of different data science contexts, but in particular, we are motivated to apply it to psychological data, and in particular, neuroimaging data. And so I kind of feel very lucky that Professor Benyu's keynote was this morning because she gave a good primer on fMRI. And so that is a particular use case that we want to use Pliers for. And so this is just a quick overview of what an fMRI workflow typically looks like. So someone is put into a scanner, they're shown a bunch of different stimuli and asked to do some tasks, and then their brain responses are recorded. And then according to the experimental design of the stimuli, or different aspects of the stimuli, aka features, those are fitted to a general linear model to predict brain activity over time. And so as a result, you get cool brain maps that look like that, that show which parts of the brain responded particularly with more or less activity in response to different features of the stimuli. So some problems with current fMRI research now is that a lot of researchers are manually annotating their stimuli, and this can be a very slow and expensive process, as you can imagine. And so Pliers will firstly solve this problem of manually annotating things. And in particular, this makes it difficult to use realistic stimuli. So this morning we saw an example of using it or example of movies in fMRI workflow, but those researchers had to manually annotate all the features across time. And a lot of researchers don't like doing this, so they use more simple stimuli and tend to veer away from more complex video stimuli, which are better because they're more realistic and more ecologically valid. And then in addition, researchers tend to only manipulate one or two features at a time for one particular modality. So maybe just experimenting with faces and the presence of faces in stimuli, even though stimuli probably vary across many different dimensions like brightness or amount of color and things like that. So Pliers really tackles all these different issues and allows fMRI researchers to very easily specify simple model or simple feature extraction workflows that can extract a lot of different features from a lot of different modalities in their from their complex stimuli and insert these into their workflow. And so this is just kind of a neat visualization of the output of Pliers. As you can see, there are a lot of variety of features that are extracted from the facial detection in the video to in the top right, some object recognition tags, and then in the top or right middle, we have the speech words that are occurring, and then the bottom right, we have different lexical features from that extracted speech. And this is kind of just another visualization of the same output, just put into a timeline. So on the Y plots, you have all the different features and their values, and then the X-axis is just the running time of the video. And so something like this in the output from Pliers can be inserted into the same IMRI workflow. We can run it and look at which regions of the brain responded to the presence of these features in our stimuli. So you get output that looks like the maps on the right. And the red just indicates greater activation when that feature is present. And so now I'll just talk about some of the general limitations for Pliers. So first of all, scalability is kind of a concern. We did not explicitly try to address scalability when developing Pliers, as we intended Pliers to be used by small to medium data science pipelines, particularly for research applications. But we do think that it still has a lot of use cases when a data scientist wants to just quickly build a model and not worry about feature extraction or needing to customize across standard feature extraction methods. And secondly, since we incorporate a high level of extraction in Pliers, you kind of lose an inherent amount of control over the feature extraction process. So kind of going back to the original point, in a production setting, you're more likely to just end up writing your own custom feature extraction code anyway. So Pliers isn't as suited for that use. And thirdly, maintenance is kind of a big issue since a lot of feature extraction methods are constantly evolving and updating. It will require a lot of effort on behalf of the Pliers developers to maintain the package to provide users with state-of-the-art. And then lastly, as I said earlier, there are just a limitless number of extractors out there, and we can only cover a small portion. So in particular, so far we've only implemented feature extractors that are useful in extracting psychologically relevant features. But we're trying to expand on that and write code for extracting more general purpose features, like those from music IR domain and filters and extractors from scikit image. And so just going back to recap here, Pliers is a open source Python package that does feature extraction in a standardized, easy to use, extensible, and multimodal way. And that's it. If you want to contact me, there's some information. This work was supported by the National Institute for Mental Health, and I'll take any questions now. Thank you.